Morning, everyone. Morning. Right here. Good morning. So welcome everybody to the day 2 of our conference of electric and autonomous vehicle new product development digitalization. Just a couple of base rules, just to make sure that everybody has, a brochure and agenda for the today. It's on your table. The breaks and lunch times are very specifically denoted, so that now we know when we can go get a break. Please keep your phones on silent so that we can start off with the first presentation that we have. The first presentation that we have is on model-based design and digitalization by Chad Kymal. The business environment has changed in the last 20 years, while many organizations have not changed. Now, why do we say that? It's mainly because yesterday, like one of our presenters was saying, as technology grows, there is a lot of resistance in adapting to newer technologies, and people are more comfortable in using Word, Excel, PowerPoint as their major new product development, or Excel spreadsheets for tracking all your project details. So here, what we're trying to do is trying to give you a perspective on what has to change in the new era. New product development now connects the system, the subsystem, hardware, software, and supply chain via requirements that flow down while testing that flows up. So this is not very easy to be done in Excel or any of the MS Office tools. Design needs to link to manufacturing, passing the requirements to the PFME and control plans. New product development requires connected audit software, problem resolution software, requirements management, configuration management, testing software, FMEA, and much, much more. Does the C-suite and senior leadership have the knowledge on challenges their teams are facing without the interconnectedness of AI and machine learning or any of the emerging tools to support the new era? Let me introduce our first speaker, Chad Kymal. He is the CTO and founder of Omnex Incorporated. He is a well-known author of 7 books and more than 100 papers, including several on integrated management systems. Chad is on the writing committees of many standards, including the TC22, SC32, Working Group 8 for ISO 26262, functional safety, ISO Technical Committee 176 for ISO 9001, 2005, ISO TC 207 for ISO 14000, and PC 283 for ISO 45000 health and safety management systems. He has founded and was a CEO of an automotive registrar for over 10 years and is familiar with conducting audits and being witness for audits and also elevating auditors and assessors' capabilities. Just to give you another idea, Chad has spent over 20 years in systems, hardware, and software development in various capacities. He assesses and works in automotive systems, hardware, software for Agile, ASPICE, and functional safety, ISO 26262. Chad is also an INTAX certified principal assessor for automotive SPICE. May we please put our hands together and welcome Chad Kymal, who is going to take over for the presentation.
Hi, good morning, everyone. We have some new attendees today that were not here yesterday. And for them, this is much more of a digitalization and AI conference that starts today for them. So we are joined today by aerospace and medical devices, organizations. And this afternoon, we'll actually split into 3 different conferences, and it'll be led by Craig. Where are you, sir? Craig Thompson is going to be leading the aerospace conference, and then medical device is by Mike Checketts. Okay, so all right. And so today, if I don't hit all the buttons I need to hit, it's because the development process is a little bit different in each of those industries. So I'll try to talk more about the principles, in terms of how our software or how model-based. Remember, the talk is about model-based design and digitalization and the culture change we need to do. So the software is more easily adapted and inside our organizations. All right. So what this picture is showing is what I'm trying to say is the old paradigm in the automotive industry, which is actually the paradigm today for, I don't want to say it in a bad way, but the aerospace industry is currently trying to adopt APQP and PPAP and FMEAs, the MSA, FMEA, PPAPs throughout their supply chain. So where, the coupling, we call it a loose coupling. I think at least the audience here in this conference understands the idea of coupling and the idea of the coupling is the coupling between the system product development, the subsystem product development, and the hardware and the software. In APQP, that coupling is not there. Everybody performs by APQP. The relationship between system and subsystem and hardware and software is maybe only through characteristics or functions and requirements. I'll talk more about that. All right. So project reviews, checklists with green, yellow, red ratings, GYR we used to call them, and we call them still. APQP and PPAP, FEMA, and then characteristics and/or requirements. All right. What do we do with it? We have project management software. We have, sometimes it's SharePoint, sometimes it's just folders where we store documents for APQP. And then PPT slides for project reviews. And, as Anthony likes to say, the biggest competitor for our FEMA software is Excel, right? Excel. All right. So I'm going to be talking about two different types of product development. So this is one that's the automotive industry is moving into this paradigm of, especially with the electric vehicles and autonomous vehicle, where the coupling between the system, subsystem, hardware, software, circuit board, in the hardware, into the components in that circuit board, all are tightly coupled with requirements flowing down and testing flowing up. And so we have ASPICE. So I'm not quite sure my latest change got in. Because everywhere there's ASPICE, I put down software. Maybe it's there in the next slide, okay? I just wanted, we're just talking, when we talk about ASPICE, we're talking about software coming in greater amounts into the overall development, all right? And so in this paradigm of safety and cybersecurity, and it's not infrastructure cybersecurity, we're talking about product cybersecurity, which is tightly coupled, functional safety, which is tightly coupled. Again, what do you have to do for each of those? You take a risk process on the top, you identify, functions and requirements, which are safety or cybersecurity, and you have to flow it down throughout the organization, throughout the product design teams inside our organization, and then to the supply chain. And we coined a word, a design supply chain. There's a whole design supply chain in this complex, coupled automotive, environment. How about medical devices? So medical devices, again, it's not mandatory. FDA has not mandated that you have to do ISO 62304. There are suppliers who are adopting 62304. We'll ask our speaker this evening, or maybe Mike knows, why, we have several of our customers in medical devices who, of course, have software, and they're, deciding to go ISO 62304. If you go ISO 62304, it is not as much as ASPICE, but it's about 60% of ASPICE, we would say. But the coupling comes in because the system and the software, you have to number the requirements in system, and it has to be traceable to the software. Soon as you do that, very much becomes coupled. And then how far you go with that, it couples you tighter and tighter. So what else is happening in medical devices is mandated cybersecurity standards. And the cybersecurity standards, as you can imagine, it's huge, right? You don't want, any kind of a medical device, you don't want to be hacked in, because it's, especially if it is a class 3, right? So cybersecurity, especially when you talk suddenly product cybersecurity, there's that coupling that comes in yet. But there are no standards yet that, as ISO 21434 for the automotive industry, we don't have standards like that yet in medical devices. So I'll call medical devices right now. Well, I wanted to say one more thing. There's an ISO 14971 that talks about product safety. As you can imagine, product safety is a big deal. And the whole ISO 14971 is about hazards. So I would call medical devices sort of medium coupled. And aerospace, the only thing in aerospace right now is a flow down of requirements. This year, or next, the new standard coming out, IA 9100, requires flow down not just to your second tier or the tier 1, but to your sub tiers. So maybe a little bit more coupling than before, but pretty much we say does not require tight coupling. I hope you all appreciate what I'm trying to say. All right. The idea of, what kind of a model should the software have also is where we're thinking about when we think about model-based design and digitalization. So you can I'll just go on here. On the top, of course, you see APQP. We teach APQP inside the medical device organizations, okay? Or we'll just call it phase gate new product development process with inputs and outputs in each of the phases. And then you can see here AS 9145, okay, which is the aerospace APQP. In fact, Dan was Dan, I don't know what your designation was, but he was invited into the AAQG and the IAQG to help them get started when the aerospace industry got started with APQP and PPAP. All right. So what are the challenges then? The challenge really comes in with software and new product development. And the idea being we are yet, especially, it's very new, and we haven't learned how to integrate that with a new product development process. And a tremendous number of new people, not only in automotive, it's in medical devices and aerospace, are coming in who are, may not have the culture of that industry or understand that industry as much, but suddenly with the idea, of course, what's driving it is the Internet of Things and the amount of technology coming in to each of those. Especially in medical devices, right now, a lot of cloud-based, implementations. I'll just tell you, we helped Amazon with 2 medical devices to help them, and one of them was cloud-based. I don't think the first one was not cloud-based, was it, Mike? Okay. All right. So what's happened is, as this change is taking place, the top management does not fully understand the software groups and how to measure and manage the software development that's going on with this new product development. So you can see here, this might be sort of these are huge programs. Even in tier ones, it's a huge program. So you can imagine inside a OEM how complicated it is. And let's see here. You can just see here on the left-hand side there, you are seeing, I don't think the cursor comes through, does it? Okay, I don't think so. You can see the BOM laid out. Okay, think of it just as a BOM laid out on the left-hand side. And in that BOM, requirements are flowing down. In a highly coupled design, all the requirements flow down. They have to be identified, they have to be traceable, they have to be consistent, okay? And then in this environment, you also have, by the way, aerospace, as you can imagine, has functional safety. And this year, IA 9100, or not, I want to say this year, but it hasn't come out. It's going to either come out next year or 2 years from now, the IA 9100. Right in the standard, they always had safety, but it's brought in to the aerospace standard, the idea of doing hazard analysis and so on, okay? And I already told you, medical devices always had it. All right, so if you look at this, so of course, there's the whole V there in the highly coupled design. Anytime you have software, the V comes in, but in ISO 62304, they did not dictate the V on the system, they just dictated the V on the software, okay? All right, and this is, even though this is showing actually the functional safety team, which is quite complicated by itself, and sort of ASPICE happening separately, and the design happening separately. So you could say we call it a highly coupled design, but it should be coupled. You can just say not coupled, should be coupled. I'll show you a different diagram in terms of being highly coupled. Well, there you go. When you start feeding things back and forth to each other, it starts becoming highly coupled. All right. So especially in the automotive design, we have now seen several different large implementations go awry. And when we look and see what's going on, number one, I already mentioned to you, it is they're trying to manage a new paradigm with the old paradigm indicators and the experience. And I mentioned this yesterday, that it took a long time for the automotive industry to really get to where we are and to be able to manage the way we are. So it's going to take some change, and that's a culture change we need. So one of that part of the culture change, of course, is that we need a whole different set of KPIs. And we need to recognize what is a bad project. Let me just tell you, we saw whole functional safety being done in one of the organizations we work with, where no characteristics went into manufacturing. So, are you surprised? You shouldn't be too surprised, right? Because in functional safety, there's still this idea, it's only product design. They think it's only product design, and it doesn't go into manufacturing. So, what's that in part 2, where you have to have that, what is that document called that top management needs to sign? Anyway, we have not the safety case, but it's what is that, Greg? Yeah, release to production. There's a release to production that needs to happen after the safety case is done. And we say top management needs to sign it, right? Why should somebody at a lower level, when they know nothing was quite done right, be on the hook to say everything was done, everything is fine, there's no risk. So soon as that top management suddenly has to sign, a lot of questions get asked, and things start to improve. Okay, and of course, and then after that, manufacturing needs to understand there's a whole part for manufacturing in ISO 26262. All right. All I was saying is, when these new things come in, a lot of people don't know what to look for. They don't even know if a safety case is good or bad, right? How do you know if a safety case is good or bad? All right. So you have to know there is a problem. So why don't I recognize the pain? Some of the implementations we did, it didn't happen till it hit the customer and went into the product, and suddenly lots of issues, including software issues. When you go back into the ASPICE project, you find out about 20% of the requirements are still in the system, that they haven't. It's waiting for some kind of decision inside the team in terms of releasing those requirements. So that is a huge problem. It should have been a red flag right off the bat. But if you don't have an indicator to indicate that, you'll never know. So folks, this is what happens if, let's say, when 5% of the requirements are not done, what'll happen is there'll be like, let's say it's 100 requirements. You'll have 200, 300 test cases. And then from there, it'll multiply into software requirements, hardware requirements. So it flows like that. And suddenly it's a lot of work that still has to be done. It's a huge amount of risk. So we have gone into projects and flagged all these high risks because they didn't know. Maybe the teams knew, but at the higher levels, they didn't know. All right. What else do I want to tell you here? I talked to you about the software bugs and system, lots of safety risks we found because we went and evaluated the safety case. We went and looked at the cybersecurity case. Both of it, we found real issues with it. For example, the product had been updated and revised, and the safety case had not been, and the cybersecurity case had not been, for example. So what do we do? So this is a continuation. It's nothing new from what I said yesterday in my first presentation, but I'm going to add to it by saying the new product development process needs new KPIs. Because it's a coupled, by the way, this is not for everybody in the aerospace industry, and you just need to have KPIs with new product development, okay? But for the new paradigm, it's different KPIs. And in an especially coupled supply chain, the design supply chain, you need to have one source of truth. What we mean by that, I think you saw some of the pictures yesterday about we have a design team here, we have a design team in Europe, we have we have software being done in India, we have hardware being done in China, we have testing being done in Mexico. So you need to have a single source of truth. Third, there needs to be a culture for model-based design and digitalization. So I'll just say this, whether you do just, I'm going to show two different models because today is a software day. Bring in our software. We'll talk to you about what we call the EVAV platform, which is highly coupled, and a new product development APQP platform, which is less coupled, okay? In both of those, you still need to have a culture for model-based design and digitalization. We'll talk to you about what is model-based design. And then what else you need is you need training for management and engineers. You need to train all the way. I didn't say top management, also top management. And then you also need to have tools with model-based and digitalization. So this is the idea of integration, the idea of bringing in, and whether you're in aerospace, medical devices, or automotive, you still have software. By the way, there's software also in aerospace. I may not have mentioned it. It's lots of software, right? AS9115 has been a software standard that's been there even, I was on the committee in 2016 when it came out. I'm on the committee now also, trying to bring in more, I won't call it A-Spice, but more that allocation needs to be there. It mentions it without any of the details, so nobody's implementing it. Okay. So software is there. There is all three of the industries also have product safety. And the HARA is a great tool to capture that. And in terms of cybersecurity, product cybersecurity, TARA is a great product to capture that. So anyhow, whatever it is you're doing, you need to align it and integrate it into your new product development process. So a couple of thoughts here. Align program management, your software project management, your safety planning, and your cybersecurity planning into one program. Align the phases. I said this yesterday also. If you have phases for new product development, all these other programs should also have the same phases, same deliverables, and it needs to be summed up as it goes up in terms of you need to decide what are the reviews, and the reviews all need to add up.
Yeah, I think a good word for it is convergence.
Okay.
They need to converge.
Okay.
In your project reviews.
You had a better word than that. How did we add up the metrics? Okay. All right. I'm looking for that word. I was searching for that word myself. Okay, I'll call it convergence for now, but the idea that it should add up to the top, okay? In terms of as you do project reviews, just like management review, we say it needs to add up, okay? You need KPIs to include metrics for software, safety, and cybersecurity. By the way, on all three industries, you need that. And they're not there if you haven't done cybersecurity before. And if you haven't done software before, I'll tell it today. I usually joke, but I'm not too far from joking on it. I call software the forgotten stepchild. They're abandoned somewhere and they're working on their own. I recall, this is many years ago, I went to do an audit and I just said, hey, what's that department over there? Because they had left them out. They said, that's software. We're doing a full site audit and they completely left out the software group in there. And so I've been canvassing for software to be called out in the scope. As you know, the definition of product is who is going to give me the ISO 9000 definition of product? I know, Medat, you should know that by heart.
Yeah.
I'm also not suddenly getting it off the top of my head, but it includes, includes hardware, software, and service. But okay. Okay. So you definitely have to put a product scope. You need to put down, it's also software. I think you need to do that because you're clearly calling it out. As soon as you call the product out, you're calling all the processes that belong to it. Dan, I didn't mean to cut you off in there, but they did some changes to the definition, right? They broke finally. They had service in the definition of product, but then they separated because they felt it was being left out, right?
Healthcare was projecting they didn't see services in standards, so they broke the services. Healthcare could see themselves in standards of service.
Okay, thank you. So, depending on how coupled you are in terms of so everybody is coupled to some degree. In the one extreme, you have requirements and PPAP, okay? That's the most uncoupled, but that's still coupled, right? But it's not as coupled as requirements flowing up and down, change requests going up, testing flowing up, and so on, configuration. So this is our highly coupled platform. And what you're seeing here, this is a battery pack. You'll get a much better look at it. On the left-hand side there, you're actually seeing the battery pack right down to the last level you can do. And if you click any of the parts of the BOM of the battery pack, this whole page will change. So what do you have in this page? Let's look and see. So there is the structure of the BOM. You're seeing the timing plan, the project plan. You're seeing requirements down below. You're seeing the configuration. And again, remember these are widgets, and you can bring in whatever widget you want. All right. And you're not seeing it really big because I'm just sort of illustrating that, right? And in each of these, the idea is with one click, you should be able to access anywhere you go. This is the one page of truth in a highly coupled design where multiple people, a far-flung, where it's even the smallest product I've found has got 100 different suppliers. So how can 100 different suppliers, because I'm talking not about the second tier alone, third tier. How am I doing on time? Okay, I'll go pick it up.
Chad, just to comment, and it's not telling tales out of school, at a company like Intel, for one project like that, we found that there were 64 different units around the world that were involved in developing that project.
And it was just one platform.
Yep. One. Nice.
It's amazing. All right, so you get the idea, and then here is the least coupled, which is just with APQP. But what you're seeing here is you're not seeing the APQP project, which is a widget. But you're seeing in every one of them is a dashboard, right? It's telling you what is the status of every project, GYR. But GYR could be just timing. We do timing. We do the quality of the event, as we call it. And that's the valuation of each product, work product. And the third one in APQP, we call them deliverables, right? And the third, of course, is your budget. All right. So the idea of a model-based and digitalized. So let's go on here. I want to talk to you also about culture. And I borrowed heavily from ISO 10010, quality culture. I mentioned to you that I was the US expert on that. The idea of creating an engineering culture statement, aligning the mission, vision, values, culture statement, and the objectives of the engineering and manufacturing team. Leadership and management is trained and provide a model for change. Integrating in engineering cultures with business processes. Appointing engineering culture champions throughout the organization, developing measures, and assessing progress. Now, depending on the amount of change you need to have more of these processes. If you think you can do just some of it and the organization will change, then maybe you don't have to do as much, okay? So I put in a little more than maybe some of you want to see right now, but it depends on the challenge that you have in bringing about the change. So training is very key, is a key part of the culture change. It should be coupled either with the less, let me not use the word coupled in too many different ways. Your training should be with either of the models that you have to do, senior management training, middle management training, and the model-based design will provide the discipline and digitalization to make things happen. All right. So I'm just calling this a model-based design example with the idea that, both the different examples I showed, highly coupled and less coupled, are both model-based. What does it mean to be model-based? The idea is, so here you can see, I tried to show a very, where the design all feeds in through one set of allocations, where really the cybersecurity and functional safety teams are doing the HARAs and the TARAs, okay? And when we talk about the model-based design, it's really about the seamless transfer from process to process. I forget, one of the case studies we're talking about where they said they have to take whatever they did, put it into an Excel, and then they put it into an email, and then they send it. We shouldn't have to do that between process to process to process. It should seamlessly go across. And so what do you get with model-based engineering is what we call model repositories. You have a system design model, and you can create variants of it, a hardware design model, a software module, and these are all qualified reuse information from a base platform that you can reuse. So you can see here in that vehicle variant, folks, on our software side, take good note. This is what we're looking for, so that we still need to be able to put together the BOM any which way we want, based on proven design. Soon as we put the BOM together, immediately I should get everything with it, okay? Of course, if they start changing the requirements, for those requirements, we'll have to go create the linkages, but with everything else, we should have everything else we have learned. And of course, we want AI to work on top of it. All right, but I'll get to that in 1 second. This is about the digitalization part of it. Only to say, today I'll just say this, that when you do new product development, you actually will have way more work products in this. But the idea is to make each of these work products or deliverables digital. And as soon as you do it, we can collapse the amount of work that's needed. But it doesn't happen by accident. It doesn't happen just because you have software. Somebody else with deep technical knowledge will have to work and consolidate it, okay? Otherwise, if you just do something, you may end up having two of each or three of each. But you have to do that database, in terms of how you set everything up. And then, the 400 will go to 200. 3 minutes. All right. So model-based design goes hand in hand with AI. And you saw that great presentation yesterday on AI and model-based, and the idea of checking first, recommendations next, and reuse. Folks, next year, when we do this conference, we have a lot of AI now. We're going to have a tremendous amount of AI in our EWQIMS platform. Summary and conclusions. The current environment in the automotive industry is fraught with change. As the industry is going from combustion engines to electric and autonomous vehicles. The change in medical devices is not as drastic, but it is drastic in the sense that big changes are happening in the medical device industry because of the hardware and the software and the cloud-based solutions coming in. And a lot of software is coming in, and cybersecurity is becoming key. In the aerospace industry, all of this is happening, but somehow I think it's just being handled by the large, Airbus and the Boeings and the, are handling the idea of there's a lot of autonomous even there coming in for airplanes. Okay. And of course, cybersecurity is key. And you can see that now in the standards. All right, let me go on. And whether you're doing aerospace, medical devices, or automotive, it's a design change and a paradigm shift. And with that, you'll need to think through what is a culture you need, and you'll have to sell that culture inside the organization for it to be more easily understood. Leadership and management needs to be trained, need to develop measures and assess progress. And the culture change needs, of course, the whole culture change is about model-based and AI and machine learning. It should go in concert with the theme of what the product design overall is trying to do. With that, so each one of the companies, we have several customers here using our software. You have to understand part of what we all have to do is to be able to explain what the software is trying to do and what it's trying to accomplish inside the organization. And that statement needs to come from the highest levels of the company and also in what we call the culture change champions throughout the organizations. With that, thank you all very much.